let's go ahead and make a start. My name is Simon Nicholson. I teach in the Global Environmental Politics program in School of International Service here at American University. And I'm one of the co-founders of the Washington Geoengineering Consortium, along with my well-dressed colleague here, Will Burns from Johns Hopkins University, and my less well-dressed colleague, Michael Thompson, over against the far wall. The Washington Geoengineering Consortium has been set up as an academic enterprise to help develop a more robust conversation around geoengineering. And we're co-sponsoring this event today because there have been some interesting statements about geoengineering in the Intergovernmental Panel on Climate Change fifth assessment report, which has been rolling out over the last handful of months. The IPCC, this Intergovernmental Panel on Climate Change, has been around since 1988. It was set up by two organs of the United Nations system to provide regular and authoritative statements about climate change science. And since the second assessment report, there have been very short and tentative statements about geoengineering. In this most recent fifth assessment report, we're starting to see a more robust characterization and interrogation of geoengineering options. And what we're looking to do today is to unpack what the IPCC says about geoengineering, and also to delve more generally into the conversation about geoengineering, how it's developing in DC and more broadly. To help us with this, my colleague Will Burns is going to speak for about 10 or 15 minutes to lay some context for us, to provide his analysis of the IPCC report and what it has to say about geoengineering. We're also then joined by two colleagues from downtown. Shravya Reddy in the back corner is director of the Science and Solutions team with the Climate Reality Project, which is an initiative which was established by Al Gore, which, according to their website, is set up to unleash a global cultural movement demanding action on the climate crisis. And Janie Weiss in the front here is senior associate with Cassidy & Associates, one of DC's best-known government relations firms. Janie works primarily on energy and climate concerns. Before she joined Cassidy, she spent time with the Department of Energy and the House Committee on Science and Technology. So with those introductions, let me turn to Will.
Great. Thank you very much for coming. I'm going to try to address three issues here. First of all, because I would assume not all of you live and die and focus on climate geoengineering, I'm going to give you a brief overview of the concept itself. Second of all, talk about the treatment of climate geoengineering in this fifth assessment report across the three working groups that looked at this issue in this context. And then finally, talk about some of the things that weren't really addressed in the IPCC reports very briefly. So first of all, a very brief overview of what we mean when we talk about climate geoengineering. The best place to start is a working definition. This is from the National Academy of Science. So options involving large-scale engineering of the environment in order to combat or counteract the effects of climate change, climate changes in atmospheric chemistry. And virtually all definitions use these key concepts: large-scale, some kind of geoengineering architecture, and efforts to address potential climatic impacts associated with anthropogenic climate change. In most cases, climate geoengineering is contrasted with two other approaches to addressing climate change, and those are mitigation and adaptation, and these are definitions from the IPCC again. Mitigation, again, is an anthropogenic or man-generated intervention to reduce the sources or enhance the sinks of greenhouse gases. And sinks are things that can store greenhouse gases, most prominently carbon dioxide. And that adaptation is adjustments in either human institutions or ecosystems to either live with the impacts of climate change that we must live with, or to try to gain some advantages associated with those changes. One of the things to emphasize is that the IPCC has indicated that some climate geoengineering approaches in some ways blend with mitigation approaches, in the sense that there's an emphasis in some of them on trying to enhance sinks and facilitate efforts to take in more carbon dioxide. So the lines between these different concepts aren't necessarily as clear as they might initially appear to be. In the field of climate geoengineering, we generally look at two broad categories of options that could be utilized. And those categories are what we call solar radiation management approaches and carbon dioxide removal approaches. Solar radiation efforts attempt to deflect some of the incoming solar radiation back out into space. If that radiation doesn't reach Earth's surface and seek to escape again and be trapped by the greenhouse gases that absorb them, then it exerts a cooling impact. Okay? The second approach is carbon dioxide removal. And that is, it gets at the source of radiative forcing. It seeks to reduce the amount of greenhouse gases, most notably carbon dioxide, that are in the atmosphere. As a consequence, there's less of those carbon dioxide to trap outgoing radiation, and again, it can exert a cooling impact. And so the technologies we look at broadly fall into these two categories, and we'll look at how the IPC now looks at those. Climate geoengineering was notably addressed in all three of the working groups of the Intergovernmental Panel's fifth assessment report, across a fairly broad spectrum of issues, looking at potential impacts, their rationale, even to some degree the ethics of using climate geoengineering were looked at by the scientists. And in the third working group, the IPCC outlined three rationale on why the society might seek to pursue climate geoengineering approaches. The first of these is what I would call the emergency approach. Okay? Humanity could end up in a situation where deploying geoengineering, particularly solar radiation approaches, appears as a lesser evil than unmitigated climate change. This is a scenario in which you have a climate change gone wild, essentially rapid melting of the ice caps, rapid sea level rise, etc. And the argument is that solar radiation management approaches, which can quickly reduce climatic impacts, might be utilized as a way to ameliorate some of these impacts that we're looking at. The second rationale is what I would call the economic rationale. It would be cheaper to address climate impacts through geoengineering than it would through mitigation or adaptation approaches. Okay? Some estimates, for example, for solar radiation management indicate that the cost could be a 10,000th as much as seeking to mitigate emissions under most scenarios. And then the third potential rationale is what I would call the stabilization approach, which is that in order to stabilize greenhouse gas emissions in the atmosphere at a level below the threshold at which the most serious impacts will occur, and the IPCC says that's at somewhere between 1.5 and 2 degrees Celsius, we might use climate geoengineering approaches to ensure that we don't pass those thresholds, while theoretically we work to decarbonize the world economy. And these are the approaches that the IPCC outlined and the reasons that we might use geoengineering. Now, the IPCC in the fifth assessment report embraced the categories that I talked about before, looking both at solar radiation management approaches and carbon dioxide removal approaches, with a strong bias, in my opinion, toward the carbon dioxide removal approaches. And I want to look at some of the technologies that they looked at, their assessment of those technologies, and a very brief assessment of their assessment of those technologies. So under the rubric of carbon dioxide removal approaches, first of all, the working groups looked at something called ocean fertilization. Ocean fertilization is an approach that seeks to stimulate the production of marine phytoplankton through the introduction of nutrients, most usually iron in areas that are allegedly iron deficient, but in some cases other nutrients including urea and phosphorus. And the idea is that in areas that are macronutrient rich but micronutrient poor, if you were to introduce micronutrients such as iron or urea, you would stimulate production of phytoplankton. Phytoplankton in turn would take up substantial amounts of carbon dioxide from the atmosphere to utilize in the photosynthetic process. And when those organisms died, they would drop to the deep ocean and they would stay there with the carbon dioxide that they absorbed theoretically for hundreds of years. And as a consequence, you would draw down substantially, the argument is made by proponents, the amount of carbon dioxide in the atmosphere. The reports of the first and third working groups of the IPCC Fifth Assessment observed that modeling studies estimate, however, that there's an extremely wide range of estimates of the potential for this approach. Some as low as removing only 15 parts per million of atmospheric concentrations of carbon dioxide, which would hardly make this approach worth it given the risks, up to 100 parts per million, which would obviously be a substantial contribution to ameliorating atmospheric concentrations of carbon dioxide. However, they've also indicated that the field experiments that we've had to date, and this is the one area where we've actually had field experiments, about 14 of them to date, have also had wildly disparate results in terms of success or failure. The working group also briefly noted the potential risks of this approach, including downstream decreases in productivity and increased potential for increased emissions of nitrous oxide, a potent greenhouse gas that could offset all of the benefits of drawing down carbon dioxide. Notably, however, the working group failed to cite perhaps one of the most serious implications of proceeding with ocean fertilization, which is that because of the high signal-to-noise ratio, the variability that's naturally built into the system, if you were to seek to assess the effectiveness of ocean fertilization, it would have to be done at a scale and for a period of time that would be so great and so long that, that by the time you determine if the approach was effective, you may have irreversibly damaged ocean ecosystems. And so that concept of irreversibility is something that's important in a lot of these technologies and that the IPCC, for some reason, seem to ignore, and is certainly a major part of the risks associated with geoengineering approaches, in my opinion. The first and third working groups also referred to an approach called enhanced ocean upwelling. And enhanced ocean upwelling essentially seeks to deploy pipes in deep ocean areas and to pump nutrient-rich waters from these deep ocean areas to surface waters. And by doing that, again, stimulate production of algae and other species that will take up carbon dioxide, drop to the bottom of the ocean, and again, sequester carbon. Both the first and third working groups of the IPCC noted that this approach has not been tested, however, in the field, and that the maximum potential is fairly minimal. Notably, the IPCC failed to cite several peer-reviewed studies that also indicate that the cost of deploying hundreds of millions of these pipes would probably make this a cost-prohibitive approach. And perhaps most importantly, should this technology ever fail, or should we have to cease to use it, you would get a massive, what we call rebound effect, a pulse of carbon that had built up in the interim that would be so great that it would produce warming that was greater than business as usual scenarios. So again, a high-risk technology and kind of, in my opinion, an underestimation on the part of the IPCC of the potential threat that this would pose. Another technology that was looked at is what's called enhanced weathering techniques, which would attempt to accelerate the removal of carbon from the atmosphere by seeking to accelerate the drawdown of minerals during the chemical weathering of silicate rocks or other kinds of minerals. It would involve application of powdered minerals to the land or the oceans to artificially dissolve these minerals and seek to speed up the process of weathering and the uptake of carbon dioxide. The third working group's report concluded that the maximum drawdown would be approximately a gigaton of carbon annually. And the first working group indicated that it could also elevate pH in the oceans and help to counteract ocean acidification associated with carbon dioxide. However, while the third group noted that there would be a quote-unquote notable energy demand associated with this approach, this appears to be a massive understatement. Two recent peer-reviewed studies have indicated that the energy that would be required to extract these minerals would in turn produce levels of carbon dioxide that would be commensurate with the levels of carbon dioxide that would be taken up in extracting those minerals. And that again emphasizes the problematic role of some of these approaches. The first and third working groups also sought to address the potential role of what's called bioenergy and carbon capture approaches. This system is often termed a negative emissions approach because what it entails is using biomass, things such as forests, agricultural discards, organic waste, as a fuel source. After that fuel source is then combusted for energy production, it's contemplated that you would then use the carbon capture and sequestration technologies to store that carbon, resulting in negative emissions. Okay? Carbon capture and sequestration, as many of you will know, is a technology that would seek to collect the carbon dioxide, compress it, produce it in a liquid form that could be then transported and stored for long periods of time, hundreds of years, either terrestrially, underground, for example, in saline formations, or perhaps in the oceans. Okay? The impetus for this technology are several other parts of the IPCC report that indicate that at this point, that if we're not to pass critical thresholds, which they're now pegging at 400 parts per million of carbon dioxide in the atmosphere, it's probably inevitable that we'll need some forms of negative emissions in the latter part of the century, or we'll assuredly pass those thresholds, and they'll be irreversible on timescales of centuries. And so there's a lot of emphasis in the working group's report on this negative emissions technology. However, given the fact that this is one of the most important technologies that are focused on, I found it lamentable that there was not more emphasis on the challenges associated with using a bioenergy and a carbon capture approach. I think there's several issues associated with this. For one, it's been estimated that to draw down carbon to the levels that would be necessary not to pass critical thresholds would probably require something like 1,500 million hectares of land. Okay? It's a lot of land. Okay? And a number of recent studies, peer-reviewed studies not cited by the IPCC in the working group reports, indicate that if you were to have to draw that amount of land, a substantial portion of it would be natural grasslands, which would have serious biodiversity implications. Moreover, a recent study by Van Vuren, which is cited in the working group report, but not for this proposition, indicated that considerable parts of the areas of the world that could be used for biomass production are areas of high water scarcity. And so to utilize those lands, again, could potentially threaten the livelihoods of many in those areas who rely on that water and alter hydrologic cycles in the area. Okay? And then, most importantly in some ways, is the storage issue. Okay? At this point, there's currently 1 megaton of carbon dioxide that's stored in off the coast in the North Sea. Okay? By comparison, in order to realize the CCS scenarios that most proponents of this approach are talking about, we would need global storage of approximately 10,000 times what we're looking at currently. This would also require infrastructure, pipes, roads, etc., that would be more than double or triple the magnitude of what we use for the oil, gas, and coal industry combined. Okay? Not only does that pose tremendous costs, but as a law person, the first thought I have is NIMBY. Okay? The fact that there would be tremendous public resistance to developing all of this infrastructure and also telling people that you were going to store huge amounts of carbon dioxide under their land or in areas close to their land. Okay? We've already seen this backlash, fair or not, in areas such as Germany and the Netherlands when it comes to carbon capture and sequestration. And those were small projects compared to the magnitude that we're talking about in this context. So in terms of socioeconomic issues and in terms of logistical issues, I think one of the primary approaches was given short shrift in terms of this, in terms of these reports. Another approach is direct air capture. Direct air capture seeks to capture carbon dioxide through the use of sorbent materials, such as calcium hydroxide or silicates and amines, or to use a filtering system. Proponents argue that we could sequester enough carbon dioxide by using air capture, by the development of these artificial trees, for example, that you see on this side, to return atmospheric carbon dioxide levels to pre-industrial levels. However, as the first and third working groups note, cost estimates for this approach range from about $40 to more than $600 Moreover, the storage issues that we talked about in terms of carbon dioxide, again, would be of a huge magnitude and are not addressed, both from a political standpoint or a legal standpoint. For example, should there be leakage and damages associated with water tables or to human health or to ecosystem health. Final approach that was looked at in terms of carbon dioxide removal was something called biochar. And biochar is a process by which biomass is heated to very high temperatures in the absence of oxygen. This process then produces a high-density form of carbon, which can be used to sequester carbon dioxide in underground burial processes. The first working group noted that biochar has the technical potential to store substantial amounts of carbon over the course of this century. However, while noting that it might have adverse impacts on soil production, the working group also failed to note the potential for biochar projects to fuel huge land grabs in places such as Africa, where there have already been discussions of creating large biomass plantations for the purposes of producing biochar. The issue that must be asked is, would this result in displacement of indigenous peoples and other vulnerable people? Many of the same issues that we're talking about when we're looking at forestation projects in the context of climate change, but really writ on a much larger scale in terms of biochar. Again, the IPCC's assessment seems to be most lacking in the context of geoengineering when it comes to socioeconomic and cultural issues of this nature. Okay. The report also then looked at solar radiation management approach. And the IPCC noted, as have many commentators, that in many ways the issues, both the benefits and the problems associated with solar radiation management are the mirror image of carbon dioxide removal approaches. Carbon dioxide removal approaches would take a long time to make any impact in terms of climate. The IPCC in these report estimated that we'd really not be seeing these impacts till the latter part of the century when it comes to carbon dioxide removal approaches. SRM approaches, by contrast, can have almost immediate impacts. And we've seen this empirically in the past. When Mount Pinatubo erupted, the decrease in incoming solar radiation within a year resulted in a decrease in temperatures of 0.5 degrees Celsius, which is quite a reduction. Okay? So we know that it can happen very quickly. It's also an approach the IPCC points out and then assesses that's fraught with much more risk, at least in their opinions, than the carbon dioxide removal approaches. So all three working groups in the fifth assessment, interestingly enough, addressed solar radiation management approaches. And they looked primarily at two of them. The first of these is what we call stratospheric aerosol injection. And this would approach would disperse large amounts of aerosols, maybe as much as 5 teragrams annually, including things such as liquid sulfur dioxide, into the stratosphere. These aerosols have high albedo, high reflectivity potential. And as a consequence, the idea is that in the stratosphere, it would reflect a substantial amount of incoming solar radiation back out into space, and it would exert a cooling effect. And these aerosols would be delivered either through airplanes, airships, or even some have proposed munitions. Okay, that's the first approach, solar radiation, first SRM approach. And the second approach that was focused on by the IPCC is what's called cloud brightening. This would seek to disperse sulfates in the areas of low-level maritime clouds, maybe by using vessels such as this, unmanned GPS-guided vessels. This release of sulfates would result in the development of extra cloud condensation nuclei and new water drops in these clouds. As a consequence, the clouds would become brighter, and the theory is that it would reflect more of the incoming solar radiation back out into space, again, exerting a cooling impact. The third working group concluded that studies of SRM indicated that this could, either of these approaches could return conditions to an approximation of quote-unquote a low carbon dioxide-like state. And the emphasis here is that we wouldn't return back to the climates that we necessarily had in the past, because there's several other factors that would not be controlled by this, including precipitation, the hydrologic cycle, etc. But at least Earth as it looked like when carbon dioxide was at much lower levels would be the condition that could be exerted in terms of this impact. Unlike in the case of the carbon dioxide removal approaches, however, all three working groups unleashed a torrent of potential negative ramifications associated with SRM approaches. This includes substantially altering global hydrologic conditions, including potentially affecting precipitation and evaporation in monsoon regions, delaying recovery of the ozone layer for 30 to 50 years, reducing the effectiveness of solar power approaches. Moreover, the third working group emphasized that detection and attribution problems in field studies would necessitate deployment of a substantial fraction or full deployment of these approaches for many years before we could determine if they would work. And again, some of the implications as a consequence would be virtually irreversible in this context. And finally, the second working group raised the specter of potential international conflict associated with the negative impacts that they were talked about, and the so-called moral hazard, meaning that if the world society perceived that there was a quick fix to addressing climate change, it would be less likely to seek to substantially reduce greenhouse gas emissions, which would ultimately overwhelm the system and result in disastrous implications. In this context, I generally think that the critiques of SRM approaches were pretty thorough, though with some gaps. For example, in talking about changes in monsoon activities, they failed to cite several peer-reviewed studies that indicate that the monsoons in South Asia could be virtually shut down in some years. And these are monsoons that as many as 1 billion people rely on in terms of agricultural subsistence. We've seen after Mount Pinatubo, a volcanic event in the 1990s, the lowest stream flow of the Ganges River in history, for example. And again, that goes beyond monsoonal changes that the IPCC talked about and substantially emphasizes the risks associated with this approach. They also failed to mention several peer-reviewed studies that indicate that solar radiation management approaches could result in diebacks of tropical forests, including in the Amazon, with both feedback implications and serious biodiversity implications. And that, again, from the standpoint of looking at the risks of taking this approach, seems to be an oversight. And then finally, what wasn't discussed? Well, you can't really condemn scientists too much for not discussing governance and law issues, okay? Those of us that are law people would like to, but we realize that's not what they were seeking to do. Though there were some discussion of governance issues and ethics issues and justice issues in this approach. Among the critical issues that I think the reports raise but don't really address are the following. First of all, if we are to conduct research in the context of geoengineering in the next 10 or 20 years, at which point should regulatory oversight of that research occur? Should it occur at the lab level? Should it occur when we get to the field trial level, at some scale of field trials? And then who should regulate this? Should this be done at the domestic level? Should we trust those that are actually doing the testings, the government of those authorities to regulate these activities? Or do we need an international regulatory approach? And if yes, what regime would be appropriate for doing this? Oversight is a major issue. The third working group also indicated that some of the potential impacts of the SRM approaches could be ameliorated if we didn't go with full-scale deployment, if we did it mostly at the regional level or at a smaller scale. But this begs the question of how we determine, first of all, what that scale would be. Second of all, how would we ensure that everybody in the world would cooperate in staying at that scale? Suppose there were some countries that decided that they would like the world warmer than under the scenarios that would be unfolded, or they'd like the world cooler. How would we ensure regulation and coordination of those efforts? Okay, it seems like a blithe response to simply say that this could be done. Okay, and then finally, while the IPCC discussed the ethics of these approaches in the first working group report, including notions of justice, it did not address practical questions associated with ethics. For example, should we deploy these technologies, would we need a compensation regime for those that may be adversely impacted? How would this be paid for? How would we determine causation in cases where the monsoon was shut down, given the fact that there's natural variability in the system? Would this be practical? If it wasn't practical, would it fuel potential for additional international conflicts? These are all issues that are raised by the IPCC and not totally answered, but would be critical if we ever really think about going down this path. So overall, when I look at the assessment that the IPCC has done in terms of climate change and geoengineering, I find the conclusions that they draw in terms of the potential impacts of climate change over the course of the next century extremely sobering. But I find the potential implications of deployment of most of the geoengineering approaches that we look at as equally or perhaps even more greatly sobering. And so it's important for us to continue this discussion and to expand on the work of the IPCC given the implications of going down this road in the future. Thank you.
Well, thanks so much. Shravya and Janie, can I invite you to join us? Maybe, Will, you can sneak to that chair on the outside there. Are you able to turn off the projector, Michael? There's a button here at the front of the room. So would you mind flicking the light switch just above your head there so we can get some light at the front? Perfect. Thank you. It's probably important to note that the third working group report of the IPCC was released this morning. And so Will's analysis was pulled together in the last handful of hours. So thanks so much for your work.
I'm tired.
So, Janie.
Simon provided a little bit about my background, but I should point out when I was with the House Science, Space, and Technology Committee, formerly the House Science Committee for the House of Representatives, I was there from 2008 to 2010. And during 2009 and 2010, 2009 specifically, there were a couple of global outlets that started considering this topic at a pretty high level to sort of make the grand policy debut of geoengineering. The first to do that was the UK Royal Society, which is sort of their analog to the US National Academy of Sciences. And they put out this very thorough report, probably 200 pages, that reviewed several of the strategies that Will just reviewed, and also provided discussion on some of the policy implications and governance implications around this topic. Shortly after that, the chairman of our committee, who is no longer in Congress, Bart Gordon, who is from Tennessee, convened a joint agreement with his counterpart in the United Kingdom from the House of Commons. Then a member of the House of Commons, Phil Willis, he is now a member of the House of Lords, to consider this topic from a more formal governance perspective. So we held a series of hearings on this discussion where we brought in kind of the known authorities on geoengineering. And I should point out, it's sort of, if you look into this topic, you realize you see the same names everywhere, and it's actually something to keep, be mindful of, that this whole conversation doesn't happen in an echo chamber. So I really appreciate what the Geoengineering Consortium is trying to accomplish here, which is bring in more people to the discussion. So there were 3 hearings and a formal joint agreement, and then both of these parties put out sort of some policy recommendations for where to take the conversation. Of course, this was all in the very near aftermath after the failure of cap and trade, which, of course, it's hard to believe it now. You would never get as close as we almost got in 2009 to cap and trade becoming law, but you know, people were feeling pretty devastated, pretty discouraged. Everybody was ready for climate action, and Congress couldn't get there. So they're going, all right, geoengineering it is. I mean, that's what a couple of voices had to say. You know, 5 years later, we're in a really different place politically, and I can't overstate how important the political element of this conversation is for a number of the reasons that Will outlined. The impacts on vulnerable populations, sort of the moral hazard that this is going to draw resources away from mitigation, and so on. But what is sort of similar is we were very discouraged about our efforts to achieve sufficient mitigation in time to avoid some climactic disaster shortly after the failure of cap and trade. And what the IPCC in the grander report, outside of the discussion of geoengineering, does is shows us again how urgent the problem is and how steep the policy curve is to achieving what we need to achieve from mitigation alone. So I found it very interesting in the geoengineering discussion, which, you know, it really was only 13 pages. You could write hundreds of books on this topic. You know, it's not presented as a policy option in any way. Today it isn't a policy option, but it's embedded in this wider report that sort of spells out a little bit of doomsday, not to overstate it, but you know, they painted a stark and dark picture of how challenging it will be and how quickly we need to move in policy to get where we need to be on mitigation targets. So I found that very interesting when I was reflecting today. And I also should point out that, you know, there's all this coverage within the scientific reports, which of course there's like 12 chapters and some several hundred pages, some are shorter. But the 33-page assessment for policymakers is the summary. That's what a lot of climate staffers on Capitol Hill, for example, will review. Way fewer of those people will actually go in and get into the meat of this report. That 33-page summary did not use this word once. So it's groundbreaking that there's 13 pages on geoengineering in the meat of the report. It is very significant that the G word appeared nowhere in the summary, and I think that's probably something, a lesson about politics as well.
I'll invite Will shortly to jump in and explain to us how it might be that the G word is not present in the summary for policymakers, because that is an interesting political question. But let me invite Shravya, you to offer some comments. You can either build off what Will spoke about directly, and also invite you to talk about civil society's role in this geoengineering conversation. And if you're up to it, maybe help us understand why it is that civil society actors seem to have been a little reluctant to engage with the conversation about geoengineering.
Sure, thanks, Simon. Just a little note about myself. I work with the Climate Reality Project, and I'm the director of the Science and Solutions team, which is the group's internal research and analysis division. So really it is part of my job to help the Climate Reality Project evolve a position on any aspect of climate science or climate solutions, including geoengineering. Currently, the Climate Reality Project, like many other NGOs active in the field, does not publicly take a position on geoengineering for a simple reason that it is such a complex issue, and the science seems to be evolving and getting stronger, and so we are studying it. It has at least risen from something that, 5 years ago, a lot of groups, including ours, perhaps did not want to look at, did not want to touch, to something that we are actively studying and trying to get smarter about, because we realize that we're probably entering an era where groups that advocate for climate solutions will have to address climate engineering, geoengineering. So just to say that we are looking at it, and part of my job is to help us evolve a position. That said, I did want to note that any position that Climate Reality may take, or anything that I say here today, is not a reflection of the views of our founder chairperson. The NGO is very separate than our chairperson, so just wanted to make that clear, because I know that there are politics involved as well sometimes, and issues of perception. So, but wanted to stick as much as we can to the science, and that's why groups like ours are looking into this, because we want our advocacy to be as science-based as possible. And I and my colleagues, we spend several days, every week, every month, every time there's a new article that comes out, a peer-reviewed publication about concentration pathways, about emission trajectories, about basically trends, about where the world is going. We look at these trends, the business as usual trends, but we also look at what it would take in terms of stabilizing the climate to limit temperature rise under 2 degrees Celsius, and it becomes increasingly clearer that time is limited and that we need to do all that we can as soon as we can, and we probably need to have a number of tools or weapons in our arsenal. I mean, in particular, I think it's become increasingly clear to us that the 2-degree goal, which is something that policymakers have embraced, global leaders have embraced as a target, that we want to limit climate change this century to under 2 degrees Celsius of temperature rise above pre-industrial levels. Now, obviously, that's a value judgment that is based on a certain level of risk aversion or risk tolerance, and it's possible that leaders, may gather in 2015 or 2020 and alter that target. But as long as we are, and there's a reason they picked the target, because the science does indicate that, as you start crossing those temperature thresholds, the impacts do become more severe, and at a certain level there's feedbacks, and you just don't want to go there. So even though there's no such thing as a safe level of temperature rise, we're already at 0.8, and likely getting towards, certainly looking to, at this point, looks like if we continue in our business as usual trajectory, we're looking at something like 4 to 6 degrees Celsius this century. And so at some point somebody had to draw a line and say, well, let's tackle something that's doable, but it will require ambition and will hopefully avert the worst disasters, and that's 2 degrees. So if we really are serious about the 2 degrees, then the amount of literature that makes it absolutely clear that we should have been acting yesterday, we should have been acting the past 2 decades, but even now, if we are serious about achieving that goal, then we need to significantly reduce emissions in the very near future. We need to peak, depending on the studies you read, we need to peak by 2020 or maybe 2025, and then steeply reduce emissions, because if we wait that much longer, it's not just a question of how much more costly things get, or how much more drastic changes we need to make, but it really is a question of the fact that the climate system can't bounce back that quickly. So if we try to make the same emission reductions in 2080, 2070, we're not going to be, no matter how much we do, we're not going to be able to avert the 2-degree rise. There will be an overshoot, and then it's a question of whether we come back down or anyway. So all this is to say that because we want to be informed by science in our advocacy, we make sure to study these issues, and therefore what we're studying really does concern us, and it makes us realize that we need to better understand the options available to us today, which in my personal opinion, but also I think many groups feel this way, the options available to us today, we do not currently, in today's context, we probably don't need to look at geoengineering options, because we have other viable options that we can and should adopt. But if we're having the same conversation 5 years from now and we haven't done very much, then we might have to look at what our available options are, and maybe in order to look ahead, we should be having conversations like this between now and then.
Well, that reminds me of a point. During the 2009 inquiry, it was either the UK Royal Society or somebody that they were working with did a social survey to see how people feel about geoengineering, and if you hear about these proposals for the first time, what does it make you want to do? And it makes people want to do traditional mitigation. So, maybe here we've aired this issue, and we're approaching Paris in 2015. Maybe this is so scary that we'll make some real progress next year. I think that would probably be everybody's first goal, including people who are advocating geoengineering research.
I see 2 problems potentially with that argument. The first is a pragmatic one, and the second is a political one. The pragmatic one is that if you read this IPCC assessment report closely, it's very, very technologically optimistic, it seems to me. It's saying we can't stay below 2 degrees Celsius of warming unless we embrace things like at least carbon capture and sequestration tied to bioenergy production. And as well as embracing that, we must also embrace nuclear energy. And unless we get the sorts of benefits we're anticipating from those two technological forms, then geoengineering technologies must be used if we're going to stay beneath 2 degrees Celsius of warming. I think it's possible to read the report in that way. It's pushing us towards those sorts of technological options. My second problem with the way that you set that up, Jane, is the political side. I think it's going to be very easy for political actors to spin geoengineering technologies as a low or no sacrifice solution to the climate challenge. People will be able to say, we can fix climate change and you'll have to change nothing about your lives. These mitigation steps we've asked you to take, transforming the energy system, reducing your personal and societal consumption, not having a pet, not flying in an airplane, having a smaller house. We don't have to worry about those sorts of options and choices anymore because we can put sulfate particles in the stratosphere. I wonder what you think of that.
Well, I hope that's not how people treat it. You know, I think that moral hazard argument we know from sort of the press around what was omitted from the final IPCC Working Group 3 report and sort of the international discussions that went around forming this report. You can sort of drive a truck through what's not said, and we realize there were international debates over this topic because specifically, I'm told, I wasn't in the room, but Russia was more bullish on this topic. Russia is prepared to maybe consider this in some kind of a serious way. They have a fossil-intensive economy like the United States. And then smaller developing nations, on the other hand, they're going, no, forget it. You know, we're an island nation, or we have a lot of coastline, or we can anticipate how the ecological impacts of these kinds of proposals could be a real disaster. You know, international agreements on mitigation targets have, you know, we have the Kyoto Protocol, but I think probably its effectiveness has sort of been limited. Everybody's concerned that the next Conference of Parties in Paris maybe won't get us where we need to be, or that the goal is to get where we need to be, but maybe the only thing more politically daunting than achieving international agreement on mitigation targets is international agreement on how you would ever use geoengineering.
I just wanted to very quickly say that maybe how one reads the IPCC is even though it is basically science, you know, the summary for policymakers is often written knowing that it is non-scientists reading it or it is open to interpretation. So I'd like to interpret what the IPCC said as, yes, we have a limited, very limited chance of achieving the 2 degree or keeping ourselves below the 2 degree temperature rise threshold without immediate action, a lot of mitigation, but also a large-scale net removal of carbon dioxide at some stage. But I do believe that the way the IPCC really, you know, approached all these technologies, it's certainly value neutral. And so there are a host of, I guess, ecosystem management practices, reforestation and other such things where you can naturally sequester carbon dioxide. And so I'd like to believe that the IPCC is, while it's saying that a removal of carbon dioxide is necessary, and of course it is very bullish on CCS, and you know, a lot of literature lately has been. I'd like to believe that it still wants us to shy away from some of these more extreme methods, which it says are high cost, untested, very risky, and maybe look at more traditional ways of sequestering carbon.
So even reforestation at the scale that we need to make a dent could hardly be called a natural process. It would be a massive industrial undertaking. Will, would you like to jump back in? I wonder if you can give us some sense of why it is that this political contestation happens during the IPCC process.
Well, there's no good reason. I mean, it's just it's the most absurd thing. These guys, these scientists come together for 4 or 5 years and pore over all of this peer-reviewed literature, right? assiduously seek to pull out the scientific messages and synthesize it. And then the last week before they release these darn things, the politicians show up and twist what they're saying. I think it's incredibly reprehensible. And if I were the scientific community, I would push back and just say we won't release these if we have to have the powwow right before, because it really does change the tenor of a lot of the messages that they have. You know, maybe not so much on geoengineering, because I read this as a fairly thorough coverage of the topic without any real advocacy, and so leaving it out isn't necessarily a bad thing in the summary. But some of the other things about talking about who are the primary contributors to climate change and what it's going to mean to pass the thresholds are really serious things, and the political leaders in all three. In the case of all three working groups, stripped out a lot of that stuff in the only summary, as both these speakers have said, is going to be read by any other policymaker. You know, but that's the reality, right?
Let me invite questions or comments before I turn back to the panel with some follow-up questions.
Following up on is it Will again?
Yeah.
Your last comment, I've read that in fact the summary is sometimes written first, and then the scientists are more or less told, get the science to match the summary.
I'd like to hope it's not that cynical, but it would shock me.
You know, occasionally a reviewer claims that that's what's happened. A reviewer that does what you suggest, just wipes his hands in the whole process.
Yeah, yeah.
Fascinating conversation, as usual, the G word. Have you guys mapped any of the major funders of the research, or who owns the patents on the technology? And is that something advocacy groups should be considering when coming up with a decision?
Can you hold that question, and then we'll gather a couple of other questions too in response to a group together? Yes.
I'm a publication inside EPA, and I did read this statement for policymakers, and as you said, I didn't see any mention of geoengineering. To what extent do you think that other elements that are in the main report are not mentioned or are glossed over in the policymaker statement?
Yeah, and then sort of on that same issue, you know, you could argue, and I think so you kind of have that it might almost be a good thing that geoengineering wasn't mentioned in the summary, because that's what most people read, and that might, you know, give geoengineering more exposure than maybe it's warranted, given how unsettled the science is right now. So I was just wondering, like, do you think it's bad that it wasn't included, or do you think it's better that it wasn't included at this stage? Or maybe do you think if we do need to talk about this more?
I'll come to you soon, Jennifer. So we have a question about who's funding geoengineering research. We have a question about what else was missing from the summary for policymakers. And what are the implications of geoengineering not really being present in the summary for policymakers for the Working Group 3 report?
So I know the Gates Foundation is funding limited projects at Harvard.
Actually, I think it's Gates personally
Oh,
rather
Gates
than the
personally,
foundation, which is interesting.
Strike that from the video and the microphone. I don't want to ascribe any of that to anybody.
Yeah, so this is Gates' personal money rather than foundation money.
That's right. In the U.S., that's the only name that I know, and you know, the technologies themselves don't exist. All of this stuff is really, really bench scale. Some of the renderings that you saw on Will's slides, I mean, these things are just imaginary, and that is one thing to point out about these proposals, is that some of them are actually very familiar and have, you know, quite far along on technology readiness. We know how to capture carbon today, and you know, maybe we can get there at some point with ambient capture, but things like sulfates, I mean, there's never been a field test of any scale, unless you count volcanoes, which are happening naturally and putting sulfuric particles up into the atmosphere. So there's no war profiteering yet, if that's a sort of scary way of putting it. We don't know who would make money off of this if these technologies existed, and we don't know where that interest would come from if, say, the government started offering grant money for this kinds of stuff, but you have to assume it would be at the basic research and university level, and atmospheric modeling, sort of the early stages.
A couple of other funders. There is, I can't remember his name, but there's a tar sands magnate in Canada that's provided David Keith at Harvard some money for this research. Richard Branson in Virgin is doing some work on air capture primarily. And I think it's also interesting, when I look at Geo as a law and policy guy, it's also important to see who's funding the law and policy discussion around this. And you've got people like the American Heritage Foundation, the Hudson Institute, that have funded people to write reports like Eric Bickel and Lee Lane to talk about the need to look at geoengineering and to work the conversation. And a lot of those people get substantial amounts of money from the fossil fuel industry and have a motive to take both positions, which is climate change isn't occurring, but if it is, if you really are stupid enough to believe that, here's a much easier way to approach it, right? And that seems to be the 1-2 punch. So I agree, there's not substantial funding at this point. There's also some government funding, the Netherlands, Russia, United States. There's also co-funding. Some of the climate modeling that we do, for example, has co-benefits or co-disbenefits, as it may be, in terms of these approaches, and doesn't strictly fit under the rubric of climate geoengineering, but could be pertinent if we ever decided to go down that path.
Anything on this point, Shirley?
Just very quickly, I mean, I can't speak for all civil society groups and all NGOs, but we have not been tracking where the money is coming from and where it's going. We certainly, are trying to keep track of where the science is coming out from, and of course a lot of it is universities, and it's, of course, they must, have research grants themselves or have funding from certain sources, but we are not tracking the money at this point. But it could be an interesting thing to look at if geoengineering becomes a much more dominant part of the climate solutions conversation.
We had Australian author Clive Hamilton on our campus a few months ago, and Clive's written a book called Earthmasters about geoengineering, where he traces through some of the funding sources for what he calls the geo-clique. So he makes this point that you made, Janie, that it's a very small number of voices, people who keep on popping up in this conversation. And for a long, long time, it was a marginalized group. This is a group of people who it was relatively easy to ignore. But in the last handful of years, this is a conversation that has very quickly been moving towards center stage. And the sense of the Washington Geoengineering Consortium is that now is the time to start paying more attention to the conversation before that conversation gets calcified. The categories are set, and there's no room for discussion of things like justice.
And I'm glad that Will mentioned that there is now some U.S. government funding, because I'm not sure of the quantity of it, but it's taxpayer money, and so one should be aware that it is taxpayer money that is being given by the federal government to this issue, and it's something to, I guess, monitor.
Never with its name on it, though. I mean, as far as I know, there's been no dedicated federal research funding with the G word on it. But there is a lot of this co-benefit type research. When you're doing atmospheric modeling, it's other things that we need to know about to understand the climate system writ large. It also helps us understand what happens when you interfere. Carbon capture and sequestration projects that we have in demonstration today on coal plants, we're learning a lot about how those sorbents work to pull the carbon off the slipstream. It would work the same way if you pulled it out of the air. All of the biological proposals with aggressive afforestation or biochar, these are other things that we learn about through existing R&D programs within the government. But certainly politics dictate it would be a hard road for a big shiny project with geoengineering written at the top, or this is the Manhattan project of geoengineering. That would be politically difficult to pull off. But we can continue all the time learning more about these proposals, maybe some of the time discarding them because we discovered that they are terrible and they are the worst idea, and we know scientifically they're not viable, or maybe figuring out which proposals could have a future where we might dedicate more resources.
The Congressional Research Service has released a series of reports now in which they suggest that some government money has been going towards geoengineering research. And there have been newspaper reports, at least, that suggest some of that money is coming from the CIA, from the intelligence community, which, according to folks like James Fleming, who's a well-known historian of weather modification and other technologies in this vein, suggests that we might be seeing a militarization push, which he thinks is part and parcel of this sort of move. So there's lots to pay attention to in this space, and lots of questions to be asked about the sorts of government and other money being directed to what ends.
Well, yeah, I should point out that the National Academy of Sciences report that's ongoing this year, so the NAS is going to treat this topic in a serious manner for the first time, and there's a report coming out in the fall. We know that that was requested by 4 agencies, the CIA being one of them, and then I believe DOE and the National Science Foundation and maybe NOAA, maybe? Do you know?
I don't.
CIA is definitely party to that, and this, the whole discussion is publicly available information. That's something that the NAS discloses, who asked us for this study. So it's sort of a groundbreaking moment because they really put a name on it. We want you to spend resources on this thing. It's the G word.
So, well, maybe you can lead us into this conversation about what else is missing from the summary for policymakers and what the implications are of no mention of geoengineering.
Yeah, well, some of the things that are missing in the summaries are a really serious treatment of the feedback mechanisms, and apparently the United States and some of the European countries were concerned that this would really scare people, right? And it should. It did, So a lot of the science indicates that the feedback mechanisms mean that the critical thresholds are much lower than what a lot of the policymakers are saying, and could have far more serious implications and irreversible implications. And a lot of that took out of the summary for policymakers, which is regrettable, to put it mildly, because from a standpoint of policymakers, if we want to indulge the fiction that they're engaged in risk assessment, right, they're losing a big part of the equation in deciding how much they're willing to spend vis-a-vis what the potential impacts are of climate change. They also, at the behest of the Chinese, stripped out an emphasis on how much the top 10 countries contribute to this problem. The Chinese meme wants to be that we're one big happy family that have to join hands to address this issue, when the 10,000-pound elephant in the room is that they're now the largest producer by about 20% over the United States, and as a growing economic power, and as a country that many of us believe will lead the world at some point. Arguably, they should have a higher responsibility to address the keystone environmental issue of this century. But by stripping those kind of things out and minimizing the emphasis on how much responsibility the 10 largest powers have, I think that it'll make it easier for them to argue that everybody is part of the problem and everybody has to contribute equally, and it also contributes to this bottom-up approach where everybody gets to make their own pledges in terms of how much they'll make, and somehow magically it'll be enough. When you emphasize the true aggregation of the top 10, you realize you need a top 10 approach, that a top-up approach that addresses those top 10 economies in a very clear way, but it's gone.
Anything to add on this point? Recognize too that the Intergovernmental Panel on Climate Change still has another report to release in this 5th assessment report round. It's a summary of the entire process, the synthesis report. And that summary document from the synthesis report is typically what is remembered and read after the IPCC's assessment report round. And that is going to be an even more trimmed down version of the findings from the 3 working groups, and probably a more politicized document, in that these sorts of arguments are going to be rehashed, and we'll get a more watered down version of what the science actually tells us. We have time for another round of questions if there are others. Jeff.
I wanted to dovetail on something you said. Back in the 1950s, when us and the Soviet Union were trying to kill each other through chemical, nuclear, and biological weapons, we were in a race to develop weather weapons to kill each other. And Edward Teller, who invented the H-bomb, was behind a project to ruin the Soviet harvest, cause dissension and cause internal turmoil. this was a topic for many summits between Nixon and Brezhnev, and it resulted in the Environmental Modification Treaty that was signed in the late 1970s that we're a party to in all these other countries, and this activity is clearly covered by this. Aren't these just weapons of mass destruction covered by the NMOD treaty that are illegal?
Let me gather another question or two as well before I let you jump in. Any other questions from the floor? Please.
Just wondering when the panel might think we might actually start seeing more serious conversations occur among international organizations on governance and trying to get out in front of the issue, or do you think, is the science going to lead the policymakers, or will the policymakers start leading the scientists?
So back to the IPCC report, you said that they didn't touch on some issues or risks with geoengineering and other things that they missed. I was wondering if you could talk about maybe why you think that they weren't included, considering they looked at so many studies, why they did.
So on INMOD, I know that the Royal Society treated that, I mean, they sort of name all of the treaties that they think might already have a hook into this issue. Tried to identify what the existing coverage of these treaties would be over, say, field tests. I mean, everybody's like, I don't want to talk about deployment, but even a major field test or even a minor field test could be covered by INMOD, but maybe for you in the governance space, what did you find?
Well, what people argue with NMOD, the proponents of geoengineering, is that NMOD in Article 2 says that it only prescribes hostile uses of these weapons, right? And the argument that proponents will make is that the intent is not to be hostile. In fact, it's the opposite. It's to deploy these technologies to save us from the scourge of climate change. And as a consequence, no hostile intent, no violation of the treaty.
But they didn't say who viewed that as hostile,
right?
Whether it's the person launching
that's right.
the device or the person that's affected by it.
That's right. That would become the underlying question, and would have to be adjudicated somewhere. There's only one place it can be adjudicated, which is the ICJ. So would that happen? If I think if a country has held that and believes that its very existence is dependent on deploying geoengineering, they will do it despite what the fine fripperies of the law might tell them, as much as that pains me to say as a law person.
I'm always reluctant to make plugs, but I can't help myself. So the Washington Geoengineering Consortium has a website, and on that website we have videos by some of the people and guest blog posts by people who are working in this field, including a video from Jim Fleming, the historian who has worked on weather modification technologies. And so he walks through his belief that we can learn the lessons of history as we think about geoengineering development and deployment. And one of the possibilities he points to is militarization of these technologies in the ways that you're talking about, Jim, leading to perhaps the use of these technologies as weapons of mass destruction. It's something that we need to be ever vigilant of.
Yeah. It's one reason the CIA said, the CIA's argument on why they funded this, one of the reasons was security issues, right? International security issues associated with deployment and the conflicts that it might engender, but also the fact that even if we didn't deploy it this way, somebody else might. So,
So we have other questions about what it's going to take to develop a more robust conversation between international organizations, and then more about what's missing from this IPCC summary report, summary for policymakers.
Well, I can talk a little bit about the conversation amongst international organizations. I think, again, speaking only for my organization, but I'm sure there are others similarly situated, I think we're happy that there is a group such as the consortium and other entities that are actively looking at these ethical issues, the governance issues. I'm here in my capacity as science director, but I'm a lawyer too, and put on my governance hat, and these issues are of extreme concern, obviously, to groups like us, but the constituencies we represent. So I'm glad that these conversations are happening. But a part of me is also very glad that this is not, front and center, because we still do regard geoengineering as a sort of last-ditch option, as something that, the smart people should be figuring out just in case we need to go there. But we really want the public's attention to be on the solutions that are here and now and are fully adequate to tackle this issue, obviously with the right amount of finance and with the right amount of scale-up and infrastructure. So, I mean, you'll find that even people who are scientists who are known as advocates of geoengineering, like Ken Caldera, there's a paper by Caldera and Nathan Myhrvold from a few years ago where they don't look at geoengineering, I'll be clear, but they look at kind of what kind of energy transitions can actually help us meet the 2-degree limit. And they find that CCS, or transitioning to natural gas, will actually not help us keep to that threshold in a 100-year time frame. The only thing that can do that is a rapid transition to clean energy, low or zero carbon technologies, solar, wind, and so on. And they include nuclear too. And so the fact is, I mean, there's been study after study, report after report, NREL and others that say the technology we have today is adequate. I mean, it's not even a question of developing some breakthrough technology. Battery storage would help, but it's really a question of scaling them up and creating the right enabling policy environments. So to the extent we as international organizations engage with policymakers, that's where our emphasis is. It's to get them to create that positive environment for renewables. And we hope that this other conversation is something that we won't have to put front and center.
And there has been some serious conversation in some of the international regimes. The Convention on Biological Diversity has passed a series of resolutions indicating that only small-scale geoengineering research should occur for non-commercial purposes, right? Terms that have to be teased out, but nonetheless have indicated that that's the approach, and that's been in response to ocean fertilization experiments. Unfortunately, those resolutions are not binding, right? But they help to develop norms. That's an organization that has universal membership, other than us, of course. And then the London Convention, the conventions that govern dumping of waste and other pollutants, has not only passed a resolution that essentially is the same as the CBD, but has also mandated that any research related to geoengineering utilize a risk assessment framework that they've developed. Okay, and so you see the incipient efforts to develop governance mechanisms. I think other regimes are leery of taking this on for obvious reasons, right? Possible loss of legitimacy if somebody like Russia were to raise its hegemonic middle finger and say they're not going to listen, right, and do it themselves. Legitimacy matters a lot to these regimes. And second of all, I think that all of them are afraid to talk about it just by the fact that talking about it might make it happen more quickly. And so that's the uneasy balance, I think, for everybody. We hear that when we talk to people on Capitol Hill. If we talk about it, then it legitimates it, right? But our fear is that if we don't talk about it in the bowels of policymaking, it may happen, and those that really need to be part of the conversation won't. So I would opt more for talking about it than not talking about it. But I think a lot of the regimes are leery at the international level of getting involved.
I would just say quickly, too, I think there is some concern that rogue field tests will wag the dog for us on international regulation. The London Protocol and I guess it was just a London Protocol that was in response to a test that just a guy with a boat did up somewhere off the coast of Canada. I mean, he made a big mistake. People figured out what he was up to, and we realized, oh, we need to preclude these kinds of actions by any means possible. But you know, if somebody wanted to do the same thing at a much larger scale, and it could be really harmful and have unknown ecological impacts, then you might see one of these international bodies make a move and preclude research entirely. And then here we are with a research moratorium. We don't have any information, and we don't want no more information. So that's not really ideal either. I think it's going to have to be a delicate balance between learning more about the risks and the potential benefits, if there are any, and establishing governance mechanisms at the same time that are complementary to what we're trying to box out and what we're trying to allow people to do.
So let me see if there's another question or two, then we'll pick up this IPCC question again about what's missing, and then we'll turn to final comments. Please.
Yeah, hi. Actually, just to follow up actually on a couple of questions. My name's Alex Hanafi. First of all, I should introduce myself. I apologize for being late. I'm an attorney at the Environmental Defense Fund here in Washington, D.C., and EDF is part of an international consortium that's looking at governance of research into solar radiation management. And so we've been looking at some of the questions that we've been talking about here. And, a couple quick things to follow up on, a couple points just wanted to touch on is first on the legal kind of regimes around geoengineering. I think one of the panelists mentioned this before, but there is a study that was done essentially of all the different potential regimes that could apply to geoengineering. And it was published as part of SRMGI's, the Solar Radiation Management Governance Institute's initiatives study of the governance issues around geoengineering. And it's on the srmgi.org website, so they have a discussion of NMOD, for example, and the biodiversity protocol and various other regimes that might apply, but essentially it's a patchwork, and none of it really fits that well with either research or deployment of these technologies. So there is a gap there. And then the question about international organizations and when are international organizations going to take this up, I think I agree with what everyone has said about that. I would also kind of ask the question of where do these discussions need to take place in order to have a productive discussion in the international organizations. And I think there's work that needs to be done before you get to the level of these multilateral international organizations. That needs to happen at the national level, needs to happen at the subnational level, needs to happen among influentials in key countries, as well as countries who would be most affected by these technologies. Right now, most of these discussions are happening in developed countries. And the folks who would be most affected by both climate change and the deployment of these technologies are actually in developing countries. So there's a real mismatch right now in terms of where this conversation is taking place. And I think that's part of why SRMGI, and what it does, is trying to get these conversations going, just as the WGC is here, trying to get this conversation going in places where people don't know about this, where it's not, these kinds of conversations we're having right now are not happening. And there's very little information, and people are not well informed about the issues. So I think once you build that kind of informed citizenry as well, and informed kind of decision makers at the local level, you stand a much better chance of having not only a more productive conversation at international organizations, but also ideally kind of preventing the kinds of concerns about transnational conflict and secret initiatives and so on that can really lead to real problems geopolitically. So,
Thanks for that. Thanks for being here. Please.
Yeah, does the IPCC ever discuss the potential positive aspects of increased CO2 in the atmosphere?
So
Did you read it cover to cover this morning?
So I'll leave that on the table as a question, and also invite closing remarks. Ultimately, what do you make of this IPCC report? What do you make of the developing geoengineering conversation in 2 minutes or less?
Well, I'll just say a couple of things and leave most of the time for the other two speakers. Maybe I'll just answer those two questions that we had before, which is why didn't they cover some of the risks associated with geoengineering? I don't think it was anything intentional. I think these scientists are broadly trained, and they're trying to cut across huge amounts of literature in the context of climate change, right? I mean, we spend, or at least I spend virtually all my time on this topic now, right? So I'm going to see things that they're not likely seeing, and they're seeing a million things I didn't see in other contexts where I go, wow, you know. So I don't think it was intentional, but I think it's important in terms of the conversation to be talking about those things to kind of round it out. And yeah, the IPCC always has a discussion of the benefits of CO2. They talk about fertilization impacts in terms of agriculture and how plants taking certain routes will benefit from increased CO2, at least up to certain thresholds. So that's where I've seen it the most, and it's discussed every time.
They don't try and balance that off against.
Well, they usually do. They'll talk about the fact that while some plants in C3 roots, I think it is, or C4 roots will benefit, others won't, and then once temperatures reach certain critical thresholds, even those plants that benefit from the fertilization impacts start to suffer from the temperature impacts, and overall, on balance, once you pass those thresholds, there's no real benefit in terms of CO2 fertilization effects. That's all I have to say.
Okay. So I don't really have any comments on sort of what was missing in the summary for policymakers. I don't really know how they formed that document based on the whole body of research that they explored in the science background. But I will say, you know, it's great that you all have convened this forum, and it's good to see more faces and names participating in the conversation, because it has been an echo chamber for so long. I would just say that the inclusion of geoengineering in the IPCC report indicates to me that these proposals are not going to go away. Maybe we'll spend time on them and decide, yeah, we want to outlaw these things, maybe. But it's not going to pay to pretend that this is not an issue. It won't pay for policymakers to ignore it, and it won't pay for atmospheric research scientists not to think about it. So I hope that in the next year or two, you'll see the U.S. government maybe get its act together on at least some semblance of a policy around how do we feel about research, how do we regulate research activities that maybe only have intra-national impacts. Are we willing to put money towards this topic? What resources do we have that exist within our science agencies like NSF and NOAA and the Department of Energy to learn more? It's not useful for the United States not to take a leadership role in this space, because the conversation is ongoing and other countries are keen to it. We can either sit back and wait for the topic to get out of our control, or we can participate.
I guess that I'd like to say that the fact that geoengineering made it into all three reports of all three working groups is a sign that we are a little bit more, I guess, desperate today than we would have been 20 years ago if we'd started taking action then. That we're looking at a wider range of options, and that speaks for itself. That we're talking about issues that 10 years ago or a few years ago would have been considered ludicrous or just too extreme. And obviously there's the whole issue itself of what's gotten us into this mess in the first place is the fact that we have altered the Earth system, the climate system, and now we think we can somehow fix it by manipulating the system itself. I mean, there's that very instinctive aversion, I think, from a lot of environmentalists to that concept in and of itself. But the fact that we're here having this discussion about looking at these options itself says to me that we are in dire straits. The urgency is clear. And I am glad that the IPCC has given it the attention it has. But I'm also glad that it hasn't really elevated this issue and advocated for it, or which IPCC doesn't do, but it hasn't really presented it as a really viable option. So what I would like to see a little bit more of in conversations as they develop is discussions about cost, because I think sometimes pie in the sky ideas can seem less attractive once it's really clear what that means in terms of scale, in terms of cost, and then what those trade-offs are. So I am more interested in, you know, the conversation going in that direction. And yeah, I guess as a climate solutions advocacy group, I'll still say that it's important to study these issues and get smarter about them. But even as we talk about them, I hope that we remember and tell everybody we know, and that we actually have existing viable solutions that can power the vast majority of the planet with the right policies, with the right investment, and that's where we should be putting more of our energy, and not looking at options that are a little bit more demanding and risky and untested. And I guess I would like to, you know, take a little bit of that hope that you noted, that maybe the fact that the IPCC seems to now talk about this as something more mainstream and something more, you know, commonplace, will serve as a wake-up call to leaders at Paris in 2015, and they'll realize that, you know, this is not something they really need to look at, and put their attention elsewhere.
The Washington Geoengineering Consortium is currently planning a series of events over the coming months that will continue to build a more robust conversation around geoengineering technologies. If you're interested in being a part of our meetings and finding out more about our work, please leave your contact details with my colleague Michael Thompson. And before we close, let me thank once again Shravya Reddy from the Climate Reality Project, Jenny Wise from Cassidy and Associates, and Will Burns from Johns Hopkins University. Thanks for being here.